அனைவருக்கும் வணக்கம். Now we are going to discuss the frequency effect on polarization. Suppose if you are giving the alternating electric field to the dielectric, there is a polarization. It depends on the time. So when alternating electric field is applied to dielectric, then the polarization, it is depend on the time, that will be equal to the P naught bracket 1 minus exponential of it is minus t divided by TR bracket. This is in general the polarization as a function of time. So here P naught is the maximum polarization when the DC field applied for the long time. So it's simply called a maximum polarization of the material. Then the T is a time, the tau r is a relaxation time. So relaxation time, because there is a two dipole, it will be like it will maybe due to the collision or collision between the successive dipoles, it will just relax. So how long it will take that time to relax or to equilibrate itself, that is called a relaxation time. So this is a expression for the polarization when we are applying the AC field or the alternating electric field to the dielectrics. So if you have just read out the net polarization as a function of frequency, because we can convert this into frequency domain, then we can read out, because time is related to the you can do the Fourier transform, you can study the frequency effect on the polarization. So here, because here all the alternating fields are having the frequency, like all the electromagnetic field, the optical frequencies are around 10 to the power 14 Hz. We are seeing the optical frequency in the visible range, like infrared, ultraviolet, then other microwave, all of them are having frequency. So you can do the transform, then you can study it. If you look at this diagram, this shows the y-axis shows the polarization, the x-axis shows the frequency in terms of the hertz. So if you look at the optical frequency range around 10 to the power 14 Hz, here it will be 10 to the power 14 Hz. So only above the optical frequency, the electronic polarization only occurs, because there is no ionic here. Look at this point, there is no ionic. So orientation as well as the space charge. Why means the electron mass is so small. Even if you are applying the electric field at short time, that means the instant of time, the electron can't respond to the external field, electric field, the alternating field. That means it is enough to acting as a such small time, because we know the time is inversely proportional to the frequency by Fourier effect. So the frequency will be larger, then time is so small. That means at high frequency, that means shorter time, the electron will be response. So compare the electron, the ions, the ionic polarization, if you look at it, will be heavier, because the ions are heavier mass than the electron. Whereas positive ion as well as negative ion, including the nuclear mass, it has to orient to the external electric field. So this mass, it will take more time, that means more time, it will be less frequency compared to the electrons. So that's why the electronic frequency, it will be ionic frequency, it will be occurs at lower frequency than the electronic frequency. Look at here, it will be occur in this region. This is the electronic frequency range, even less than 10 to the power 14. Maybe you can put the 10 to the power 14 here in this here. So less than 10 to the power 14 frequency, the ionic polarization will be occurring. The orientation polarization, the total, the permanent dipolar molecule, it will change its direction according to the external applied electric field. So it will take more time compared to the electron as well as ion. So the orientation will be taking place by consuming more times. So that means that it will occur at much less frequency. Around here, if you look at around 10 to the power 6 hertz, look at that one here. The orientation polarization occurs 10 to the power 2 to maybe from the 10 to the power minus 2 to 10 to the power 6 hertz. So 10 to the power 6 to 10 to the power 10 hertz, the ionic polarization, it will be good. So the space charge, it will take even more time because the inside the dielectric material, the charges are moving for a long distance, and then due to the external the electric field, it will take more time to accumulate the charges on both side of the material. Then it will create the dipoles. So that's why if it is taking more time, it will occur at less frequency according to this equation. So at small frequency it can occur. That's why the audio frequency, radio frequency range, all the polarization will be occur. The infrared frequency range, only the electronic ionic polarization will occur. Or only optical frequency range, only one polarization will occur. That is the electronic polarization, because the time is so short, so electron cannot respond to at short interval of, sorry, ion cannot respond at short interval of time. Even orientation polarization, it won't respond to such a short interval time. That means at high frequency space charge also, only the electron can respond because of its smaller mass. So this is the one of the picture which it will clarify us about the electronic ionic space charge as well as the orientation polarization as a function of frequency. Thank you all.